Chapter 4, Cost Volume Profit Relationships. This is the managerial accounting course, native English mode. If you are English as a second language student, please check for the slower version of this lecture. Okay, let's get started. The cost volume profit relationships is an extremely important subject in managerial accounting. It helps managers understand the relationships among cost, volume, and profit by focusing their attention on the interactions among the prices of products, volume of activity, per unit, variable costs, total fixed costs, and the mix of products sold. It is a vital tool used in many business decisions, such as deciding what products to manufacture or sell, what pricing policy to follow, what marketing strategy to employ, and what type of productive facilities to acquire. So learning objective number 1. Let's explain how changes in the activity affect contribution margin and net operating income. So the contribution income statement or profit and loss statement is very helpful to managers throughout the organization when it comes to judging the impact of profits when changes in selling price occur, or changes in cost, or changes in volume occur. So here's an example of a contribution P&L for a bicycle company. Let's call it Racing Bicycle Company. And notice the emphasis on cost behavior. Variable costs are separate from fixed costs. Contribution margin is defined as the amount remaining from sales revenue after variable expenses have been deducted. So again, this is not following GAAP and cannot be published outside the organization. It's to be used internally to help management identify options and take decisions. So again, sales is always on top, net operating income always on the bottom. But in this contribution approach, we subtract variable expenses from sales. That gives us contribution margin, and then we take away fixed expenses. So the approach and the focus is, do we have enough contribution margin to cover our fixed expenses? It's a completely different format and approach than the GAAP-based approach for income statements and P&L. So again, contribution margin is used first to cover fixed expenses. Any remaining contribution margin contributes to net operating income, also known as profit or the bottom line. Sales, variable expenses, and contribution margin can also be expressed on a per unit basis, not just total dollar or total yen or total currency or euros, but it can also be expressed on a per unit basis. And this gives great help for management so that it focuses on, for each additional unit that this company, Racing Bicycle, sells, $200 more in contribution margin will help cover the fixed expense and provide a profit. So here, on a per unit basis, you can see that sales of 500 bicycles totaled $250,000, and you take $250,000 divided by 500 will give you $500 per unit. That's the unit sales price. Now we know that the variable variable expenses are 150. So 150 divided by 500 is what? $300 per unit. So 500 minus 300 is 200. You can check that by dividing this gross amount, $100,000, divided by 500 equals 200. So either way, you can do the math and it confirms. So again, for every 1 unit or 1 bicycle this company sells, it will provide or generate $200 in contribution margin, and that will go towards fixed expenses. And in this case, the fixed expenses are $80,000. So if you're making $200 per bicycle, you could divide $80,000 by 200, and you would determine how many units must be sold to break even. Break even means zero profit. That's the addition. $80,000 divided by 200 is what? 400 units. So if this company sells 400 units, 400 bicycles, it generates this total sales, $500 a piece. Contribution margins $200. 400 bicycles times $200 per unit equals $80,000. Therefore, net income is zero, so it would be break even. Now let's say that this company sells 401 bicycles. So 400 was break even. So an extra 1 bicycle, which should suggest that $200 of profit is made. You're making 400 was to cover your fixed expenses, and 1 unit would be your profit. What is the contribution approach? This is a nice way for managers to determine what's needed to break even and what's the focus is on variable expenses and fixed costs. So if we develop equations that calculate break even and net income, we will not have to prepare a detailed income statement and profit and loss statement to determine what net income will be at any levels of sales. So, for example, if we know that this company, Racing Bicycle, sells 430 units, its net operating income is going to be $6,000. Why is that? 400 bikes are required to break even. 30 bikes at $200 contribution margin per bike, 30 times 200 equals 6,000. So the company will sell 30 units above the break-even unit sales and a contribution margin at $200 a piece. And that's how you get $6,000 of profit. Nice and easy, very quick, very logical. So in an equation format, we can prepare the following basic equation. Profit, or the net income, bottom line, is sales minus variable expenses minus fixed expenses. Okay. You can see in the previous example, the same numbers appear. But now, let's put this to memory. Sales minus variable expenses, in parentheses, minus fixed expenses. So, notice the answer of $200 mirrors our earlier solution. Okay? In this example, we sold 401 units at $500. That's the sales price. There's your total. This is your total sales revenue. 400 units at $300 each as the variable expense comes to this number. and here's our fixed expenses. So this equation will give us $200 profit. Now, let's look at it in a different way. If the company sells a single product, in this example, the bicycle racing company, we can express the sales and variable expenses in the blue and brown boxes. So sales are equal to the quantity sold, which is Q, times the selling price per unit sold, which is P, and variable expenses are equal to the quantity sold, which is Q, same Q, times the variable expenses per unit, V. Okay? Excuse me, I was on the wrong side. V is your variable expenses per unit. This is the selling price per unit. Okay? So this supports the variable expenses, this supports the sales value. Okay? And here's a better way to look at this. Profit, net income equals, okay, price, P is price per unit, price times quantity minus the variable expense per unit times quantity. Both of these are by quantity per unit based. Okay? Therefore, you bring in the units here. This is your what? Contribution margin. This is your contribution margin minus fixed expenses. It's going to equal profit. Now, there's another way to look at it in the equation form. Sales minus variable expenses minus fixed expenses, same equation. So selling price, quantity, variable expense per unit times quantity minus fixed expenses. Now we're selling 401 bikes. The break-even point is 400. So if it was 400, our profit is 0. We add one extra unit of sale to make it 401. Well, 500 times 401 minus 300 times 401. Put that in parentheses to your subtraction here between this product and that product. Whatever this number is, subtract 80,000 and you have profit. $200. Very straightforward, nothing complicated here. Now, we can do the cost volume profit, CVP, cost volume profit relationship in an equation form. So here we go. The unit contribution margin is equal to the selling price per unit minus the variable expenses per unit. Notice it's per unit. Okay. So, and then the unit contribution margin will be price minus variable expense. So here we see price per unit, quantity, the variable expense per unit, quantity, minus fixed expenses. That's the universal equation for cost, volume, profit. Price minus variable expense per unit. This is per unit times the quantity minus the fixed expenses. Okay. It's just taking these two numerical values, subtracting them. The difference here will give you is essentially the unit contribution margin. Okay. Price per unit, volume cost per unit will equal contribution margin per unit times the quantity minus fixed expenses. Okay? Same concepts, it's just on a per unit basis. Okay, this is the universal equation. Here we're taking the price per unit, volume, variable expense per unit times the quantity there you go. Price minus variable expense gives you the unit contribution margin. Put the real numbers in, 500 minus 300 times 401 minus 80,000. It's 401, it's the extra one, right? So if it was 400, profit's zero, it's break even. It's 401, we find one extra unit delivers $200 more in profit. Okay, now, learning objective number 2. Now that we are comfortable with cost, volume, profit, let's put it in a graph and also create a profit graph. These provide great perspectives for management. So here we go. It's the same racing bicycle company. We create this chart. Units sold, 0, 200, 400, 600. Okay, there's your units. Here's your sales value. If you have 0 sales, you have 0 sales revenue. No variable expenses, but you're going to have fixed expenses of this. Makes sense? 0 units sold. No revenue coming in, no variable expense. No contribution margins, pure fixed costs. Now let's say there are 200 units sold. So 200, 400, 600. Okay. Variable expenses varies by unit sold. Fixed costs, fixed expenses remain the same. So break-even point, as we calculated earlier, is 400 units. Okay. Let's look at it in a graph form. So usually the horizontal, or the x-axis, is the unit volume. You can see here, units. The vertical, or the y-axis, is going to be dollars. So here we go. Here is the number of units. There is the let's pick 400 units in this example. You can plot the point representing total expenses. So here is the fixed, here's the variable, so this and this is going to add. And that's what it's going to look like. Okay. So that represents the break-even point, 400 units. Blue line is total expenses. Green line is sales. So with 400 units being sold, $50 a piece, break-even point is $200,000 in sales. If we go more than 400 units, we are in the profit zone. Here's the sales revenue. Here are total expenses. Likewise, if sales are less than 400 units, then we're going to incur a loss, and that loss is represented by this area. To look at another CVP graph, and this is simply the profit graph. So this represents what we saw in the previous slide, but it only shows the profit. It does not show the horizontal fixed expenses. It does not show the increasing sales line. What this shows the net, the profit graph. So here again, 400 units delivers 0 profit. Therefore, it's the break-even point. Moving on. Learning objective number 3. Let's use the contribution margin ratio to compute changes in the contribution margin and the net operating income resulting from changes in sales volume. Now this is starting to get more interesting. Okay. Here's the pure dollar values, and we calculate, this is for 500 bicycles, $50 a bike, delivers $250,000 in sales revenue. Divide this total value by 500 bicycles sold, you have a per unit basis of $500 per unit. So here, the contribution margin ratio would be 100%. Now, we have variable expenses, $300, okay, per unit. So 300 divided by 500 is 60%. The difference here is a contribution margin, $200. So 200 divided by 500 is going to be 40%. Now we know the contribution margin ratio per item. Very helpful. Contribution margin ratio for the bicycle company is, as you see, contribution margin per unit divided by sales price per unit gives you 40%. So we know that for every sale, 40% is going towards the payment or the recovery of fixed expenses. That's what the contribution margin does. So here, if we increase sales by $50,000, contribution margin will increase by $20,000 because its contribution margin ratio is 40%. 40% times the sales gives you the result, $20,000. Okay? So 400 units to 500 units. Sales revenues increase, variable expenses increase, fixed expenses stay the same. So that incremental 100 units sold delivered $20,000 more in net operating income. So let's check our understanding. There's a coffee shop called Coffee Clatch. It's an espresso stand in downtown office area. The average price, selling price for a cup of coffee is $1.49, and the average variable expense per cup is 36 cents. So the average fixed expense per month is $1,300. 2,100 cups are sold each month on average. So what is the contribution margin ratio for a Coffee Clatch? So what are we going to do? We're going to take the selling price, $1.49, the variable expense, 36 cents per cup of coffee. So take the difference, 1.49 minus 36 gives us a contribution margin of $1.13. $1.13. The average fixed expense per month is this number, 1,300. So if this is sold, what is the contribution margin ratio? So we take the $1.49 selling price less the 36 divided by $1.49. Okay, that's the ratio. So the relationship between profit and the contribution margin ratio can also be expressed in the following equation. So the profit of the bottom line is the contribution margin ratio times sales minus fixed expense. So if we increase our volume by 100 bikes, we go from 400 to 500 bikes in sales. What could we expect to be our bottom line or profit? So contribution margin ratio is 40%. We calculated that times 500 units times $50 per unit. So 50 times 500 is 250. So 40% times 250 minus 80,000. So we have, what's our profit? It can be $100,000. That's 40% times 250 minus 80,000. So our profit's going to be 20,000. We're in objective number 4. This shows the effect of the contribution margin on changes in variable costs, changes in fixed costs, changes in selling price, changes in volume. So here we have the variable expense ratio. Calculated this before. It's the ratio of variable expenses to sales. Okay. Variable expenses to sales. Here it is. 300 divided by 500, or 150,000 divided by 250,000. So on top, numerator, 150,000. On the bottom, the denominator, 250,000. So that ratio will give you 60%. It can be computed by dividing the total variable expenses, right, by the total sales. And that's what we get. 60% is the variable expense ratio. So what is the profit impact if Racing Bicycle can increase unit sales from 500 to 540 by increasing the monthly advertising budget by 10,000? These are the types of questions that come up. And if we have cost volume profit equations and we understand the relationships, we can answer these types of questions. So again, if the increase in unit sales is coming from an additional advertising, is this increase more than the $10,000? These are the types of questions we get asked. So let's work through the problem. Here we see sales has increased. Here we go. We had 500 units. Now we're going to go up to 540 units. The marketing department and the advertising guys say if you increase advertising, the unit sales will go up. Well, there's some logic to that, but how much are you going to have to spend in advertising to increase the sales? And is that spend offset by increasing profits? Let's work through the example. So sales revenues went up from 250 to 270. Going to take away the variable expenses. Okay. Contribution margin is then determined. The fixed expense is going to be 80,000. Here, fixed expense is 90,000. And then operating income goes actually down for an increase of 40 units in sales. The fixed expense went up by 10,000. What's that? That's the advertising. So we spent $10,000 to increase an additional 40 units. Was this a good decision? Should it be justified? The answer is no. In this simple analysis, we actually had less operating income, even though more unit sales went up. Okay? So one would show this and say, should we get the extra? Should we spend $10,000 more in advertising? The answer most likely would be no. We've actually decreased our bottom line. So in this example, we increased our unit sales by 40 units at $200 a piece. That's $8,000. But our increase in advertising to get those 40 extra units was $10,000. So the bottom line was we lost $2,000 in the process. So here we go. Let's do another example. What's going to happen to the profit if the Racing Bicycle Company can use higher quality raw materials increasing the variable cost per unit by $10. And this will be used to generate an increase in unit sales from 500 to 580. So we're increasing our unit sales. That's good. Why? Because we have higher quality. So that means probably the advertising and the campaigns will emphasize better quality. But that better quality costs $10 per unit. Is it justified? Is this a good deal? So sales revenue, we always start at the top with sales revenue. At 500 units times $50 per bike, come up with this total sales revenue. We've increased our unit sales by 80, so 580 units delivers this number. Our variable expenses increase, right? Because our quality has increased by an amount. So our contribution margin in this example improves from 100 to 110. Our fixed expenses don't change, so this is actually a good proposition for the company. Sales increased by $40,000. Net operating income increases by $10,200. So what is a profit impact if the company cuts its selling price $20, increases its advertising by $15,000, and increases sales from 500 to 650 units per month? What's the bottom line? We always calculate our sales revenue on top. So here we have $250,000, increases to $312,000. Our variable expenses have increased. Contribution margin has increased. That's good, but it only increased by $17,000. Our fixed expenses increased by $15,000. Our net income has increased by $2,000. So in this simple math, we should go forward and do it. The sales increase was $62,000. Bottom line increased by $2,000. Let's do another example. What is going to be the bottom line impact? If we do two different things. We pay a sales commission, so we motivate the sales force by compensating their efforts, so we're going to pay a sales commission per bike instead of paying salaries that don't change. So the salary base is $6,000. Doesn't matter whether they sell bicycles or not, they get this number. Now we're going to change it to a commission and increase the unit sales from 500 to 570. So here, we've got an increase in unit sales, 500 to 575. Sales revenues went up. Variable expenses went up because we're paying sales commissions. The fixed expenses dropped because we've decreased our monthly fixed salaries. Bottom line, increased very nicely. It's a good business proposition. Let's do another one. Here the company has the opportunity to sell bicycles to a wholesaler without disturbing sales to other customers. Might be in a different region. Or sales, and it will not disturb fixed expenses. So what price should we make to the wholesaler, perhaps in a different part of the market, different part of the region, if it wants to increase monthly profits by $3,000? What's our transfer price to the wholesaler? So we have $3,000 divided by 150 bikes. It's $20 a bike. Okay? Simple math. Variable cost per bike. Cost per bike, it's $300 per bike. selling price required. At a minimum, we would have to sell to the wholesaler at $320. Okay. We could do a special order, or we could do a special distribution channel to a new wholesaler in a different area of the market, different area of the country, as long as it did not disrupt our current sales operations. It did not disrupt our fixed expenses. We sold it at $320 per bike. We would have an increase of $48,000 in sales revenue there, and our total variable expenses would increase by this, then our contribution margin, which would drop to our bottom line, would be $3,000. And objective number 5. What would be the level of sales needed to attain a target profit? So here we're saying not break even, but we need to make a profit. So what's the level of sales needed? Let's see how this works. First, we can compute the number of units that have to be sold to get the profit target. We can use either the equation method or the formula method. If we use the equation method, here's our equation. Our bottom line, or our profit, is going to be the unit contribution times the quantity sold minus fixed expenses. So we need to solve for what's going to be the quantity sold to get our profit target. So let's say we want a profit target of $100,000. We know our unit contribution margin, we know our fixed expenses. What we're after is what's our quantity that we need to sell. So here it is, $100,000. It's our target profit. We get $200 per bike, and we have $80,000 in fixed expenses. So do the math. $200 times quantity. You bring your $100,000 over here, subtract the fixed expenses. Bring the $200 per quantity, which is our contribution margin. We need to sell 900 bicycles. Now we can use the formula method as well. And here is the equation. Unit sales that we need to attain a target profit. That's going to equal the target profit plus the fixed expenses divided by the contribution margin per unit. So, we want to earn $100,000 in profit. So, here's our $100,000 on this side. Here's our $100,000 up here for our target profit plus our fixed expenses, contribution margin per unit. That's going to derive unit sales we need. Here's our profit target. Here's our fixed expenses. Here's our contribution margin. There we go. 900 units to achieve the profit target. So we can compute the target profit either way, the equation method or the formula method. All right? Our goal is to solve for the unknown, which is what in this case? Sales. Here we're trying to get the profit for $100,000. How many units do we have to sell to get $100,000 profit? Okay. We have to sell $450,000 worth of bicycles at the selling price and the contribution margin to achieve our profit target of $100,000. Same with the formula method. We want to achieve 100,000 here, 100,000 profit, dollar sales to achieve it. We need to sell $450,000 worth of product to achieve the profit target. So back to our coffee example. $1.49 is the selling price. The variable expense per unit is 36 cents. What's our contribution margin per unit? 149 minus 36, or a contribution margin per unit is $1.13. And here's our average fixed expense per month. Use the formula method. What's it going to look like? Target profit plus fixed expenses divided by unit contribution. So what's our unit contribution? $1.49 selling price, 36 cents variable expense per unit. So on the bottom, we have the unit contribution. Here's our target profit, $2,500. Here's our fixed expense, $1,300. So we have $3,800 on top, divided by $1.13. 3,363 cups is what we need to achieve our target profit, $2,500. Now, let's look at another example using the formula method.
You busy?
Oh, not really.
Oh, I just wanted to tell how I figured you were still working.
Oh, yes, never ends.
What?
So here we go. The example, $1.49, 36 cents. We're going to use the formula method to determine this. Answer is, take the target profit plus fixed expenses divided by the contribution margin ratio gives us sales dollar to attain the target profit is 5,011. Now, let's get into a very frequent popular discussion of determining the break-even point. The equation and the formula methods can be used to determine the unit sales and the dollar sales needed to achieve a target profit of zero. Target profit of zero is break-even. So let's use the bicycle company to determine a break-even analysis. So we use the example 500 bicycles. Here's the total value in sales, $50 a piece. $500 a piece gives us $250,000. Less our variable expenses gives us contribution margin, $80,000 in fixed expenses. So 500 bicycles, we have a profit of $20,000. So suppose what do we need to sell to break even? Zero profit. Profits are zero at break-even point. So $200, the unit contribution margin times the quantity. Do the math, simple equation, put the zero here for profits. $200 contribution margin, we're looking for the quantity here. So what must we do? Move this over to the left side of the zero, 80,000. Divide 80,000 by 200 equals 400 bikes. Here we go. We use the formula method to come up with the same value. $80,000 is our fixed expenses divided by contribution margin per unit, $200, $400 unit sales. Now, what if we want to compute the sales dollars required to achieve break even? We're solving for sales this time. Contribution margin times sales, profit 0, 80,000 fixed expense, right? 40% times sales equal 80,000, $200,000 in sales. Now we can use the formula method to calculate dollar sales at the break-even point. Again, 80,000 in fixed expenses divided by contribution margin ratio, 200,000. Once again, we'll do our check. $1.49 sale price, variable expense per unit 36 cents, fixed expense 1,300. This is our sales in units. What's the break-even sales dollar? Fixed expenses divided by contribution margin ratio gives you this value is our break-even in sales. Okay, or 1,150 in cups. Margin of safety and its significance. Now, the margin of safety in dollars is the excess of budgeted or actual sales or the break-even volume of sales. So here's the margin of safety, total sales minus break-even sales. So if our actual sales are 250,000 and our break-even is 200,000, the margin of safety is the difference between actual sales and break-even sales. In this case, very simple math, $50,000. 20% of sales is our margin of safety percentage. 50,000 divided by $500 per bike, that's our sales price, gives us 100 bikes. So the unit, the margin of safety in units sold is 100 bucks. Quick check, same units, margin of safety, total sales minus break-even sales, total sales, 2,100 cups, right there, 1,150 cups to break even, 950 cups. Another way to look at it. So 20% of sales. This now concludes this chapter.